Hey, Gage here. Now let's talk security on Solana. Well, I'm sure there's an infinite number of exploits out there. Today, we'll focus on three: reinitialization, arithmetic, and account exploits. Knowing about these three will not only help you avoid some of the most common programming mistakes I see out there, but will help you write secure Solana programs from day one. A reinitialization attack might happen if a user passes in an account that your program expects to be closed with data it probably isn't equipped to handle. A simple solution for this is to always separate your account's mutations with their initializations or closes for that matter. Doing this is not only best practice, but will stop a lot of different types of attacks on your programs. Luckily, we haven't seen any crazy value lost with this type of attack, but I'm sure it's just a matter of time. Unfortunately, arithmetic exploits have been the cause of some pain on Solana. BlockSec found an overflow bug in the Berkeley packet filter that was allowing users to denial of service attack the chain, and Neodyme found a rounding error in the SPL token program that potentially left over $2 billion at risk. One thing I see quite commonly are people using the default Rust operators in their Solana programs. Always use checked math for your basic operations, and you can pretty much avoid all overflow and underflows. As far as rounding errors and math functions go, make sure to triple check your equations so that your program is performing as expected. Which finally leads us to the most common and some of the most painful program exploits to date: account validation exploits. By now, you should know that the user is responsible for passing in all accounts that will ultimately interact with your program. This means they can pass in fake accounts, the wrong accounts, accounts with bad data, the list goes on and on. You, as the program writer, are responsible for checking the data in these accounts to make sure that your program behaves as expected. Just this year, more than $320 million was stolen from the wormhole protocol using this type of exploit. The author wasn't checking that the system program being passed in was the real deal, leading to this massive loss of funds. So if you don't want to be the next headliner, make sure you really look out for this type of exploit. Luckily, in all three of these cases, Anchor can come to our rescue. Anchor is a framework for writing smart contracts, otherwise known as programs on Solana, in Rust. It gives us a lot of good security benefits right out the box, from account deserialization to account validation. It even lets us write our own validations, otherwise known as constraints. Now don't worry too much about the code here, you'll learn that in later lessons. What I want you to understand is the high-level overview of how Anchor forces you to separate your business logic from your validations and your models. This helps you more easily reason about the code, as well as catch potential security exploits before you ever go to market. Looking back at our exploits above, for reinitialization attacks, we can make sure that our account's initialize and mutation functions are kept separate. For arithmetic bugs, we can always use checked math in our logic and double check our equations. But most importantly, for account validation exploits, we can use Anchor's constraints as well as the deserialization provided by its models to make sure all accounts passed into our program are exactly what we expect them to be. And with that, you're well on your way to not only writing good code, but secure code as well.